So we are going to be talking about the law of cosines as a method for solving triangles. Now, so far in our studies, we have been studying right triangles. The nice thing about the law of cosines is that it is for any triangle. Right triangle, obtuse triangle, acute, equilateral. Now we're going to label this triangle. The angles we're going to label with capital letters, A, B, and C, or whatever letters you choose. The opposite side to the angle is also going to be labeled with the same letter but lowercase. So we have A, B, and C. So what you're going to get is a formula that is pretty much the same formula but expressed in three different ways depending on what you're looking for. So I'm going to start with c squared equals a squared plus b squared. Now that looks a whole lot like the Pythagorean theorem, and that's true if your triangle is a right triangle and if c is your hypotenuse. But if it's not true, we have to account for the extra or less degrees in the angle, and it turns out that we will subtract 2ab times cosine, not theta, but c. So the nice thing about this formula is that the ends will always match. Side C, angle C. Well, let's say that I don't want angle C, I would like angle B or side B. So I'm going to trade the B's for the C's, or the C's for the B's, as that case may be. And so this version, instead of ending with cosine C, is going to end with cosine B. And we would just follow the same pattern for the third one, and we're going to have a squared, b squared, c squared minus 2 times a, not a, b, b times c, and then cosine a. So in every case we have the sides, and the angles on the end are the same, and it follows the same pattern. So let's use this formula for problem solving. So I've got side B, side C, and angle A. You can draw the triangle if you wish and label it. Some people like to do that. Now, this is going to be side A down there, which means 54 is the opposite angle. And we're simply going to plug it into our formula. So a squared equals b squared plus c squared minus 2bc cosine A. And we'll just fill it in. So 10 squared plus 14 squared minus 2 times bc, then that's 140 if you multiply those together, and then cosine of 54. Now you really want to be very careful when you multiply. I prefer to put this all on the calculator all at one time, and then I don't have to worry so much about order of operations. But if you decide to split it up, you need to be very careful. This little grouping of numbers does not go together because 2 times 140 is multiplied by cosine of 54. So you need to be very careful that you don't try to subtract this 280 from these two numbers. So don't do that. So we can go ahead and evaluate these. Start our simplifying process. There's no need to round cosine 54 because we can just put that into the calculator, and we are going to do that in just a moment. So that gives me 296 minus 280 cosine 54. Now because the 280 is multiplied by cosine 54, you can't just simply subtract that from 296. Now at this point, I would go ahead and put all of that under a square root. And actually, you could do that from the very start if you choose to do that. You could put that square root at the beginning and just set it equal to a. And this ends up being 11.5 for side A. All right, now let's look at example 2. Same thing, we have two sides and the angle in between. And I'm looking for side B. So what I would actually prefer doing as far as calculator work, let's go ahead and take the square root. You have to take the square root at the end anyway. So if you go ahead and use parentheses correctly, you could put this all into your calculator, and then you don't have to be so concerned about being afraid of combining things incorrectly. And it will work out just fine if you do it like that. It is a complete correct application of the rule. But for the rest of you who don't wish to do that, we're going to write it out instead. So this is an option. The starred line is an option for you. Okay, and then let's combine our 900 with 1369, and that gives me 2269 minus 2220 cosine 102.6. Square root that whole thing like that, and then you will end up with the correct answer, which is 52.5. All right, in this next example, I've given you all sides but no angles. All right, in this situation, you would do an inverse of the cosine function, but let's go ahead and figure out which version we want. Since I am looking for angle A, I'm going to use the version of the formula that is equal to a squared. And sometimes it's just very helpful to write it out anyway. Alright, so let's start plugging in. So a squared is 14 squared, which is 196. And b squared is 15 squared, which is 225. And then 18 squared is 324. And 2 times 15 times 18 is 540. And then we have cosine of A, and there's nothing we can do with that yet. So you're going to add these right here. So 196 equals 549 minus 540 cosine A, and you cannot subtract the 549 and the 540 because the 540 is a coefficient to your cosine of your angle, so you can't do that. But what you can do is subtract 549 from 196. And you have negative 353 equals negative 540 cosine A. So we'll divide both sides by negative 540, which gives us a positive fraction. And maybe this fraction is reducible, maybe it's not, but it doesn't really matter. So remember that your A is stuck inside your trig function, and you need to get it out. And the way we undo trig functions is with an inverse function. So we're going to cosine inverse both sides, which essentially does this. It cancels that cosine. but not on the right side. We're going to keep that. So we'll have A equals cosine inverse of 353 divided by 540. It's very important that you put that entire thing in parentheses. And what this gives us is A equals 49.2 degrees. Alright, so you know me. You have to do some problem solving. This is where it's meaningful. So a surveyor, somebody who measures property lines, sets out stakes at the extreme ends of a property line. So we're going to label those with U and V. Connect the dots. And it says a point W is located such that it is 800 meters away from W and it is 500 meters away from V. So that's going to put it somewhere about right there. And that looks to be around 102 degrees. And so that makes that angle W, which means the opposite side, right here, that opposite side we're going to label as little w. And let's put in our side lengths. Okay, and this fits the model for the law of cosines because we know the opposite angle from the side that we're looking for, which is really convenient. So we're going to put all of this in our formula, like so. And maybe I ran out of room. I'm going to write it beneath, even though it's pretty bad form right there, but I'm writing it beneath. Now you can square 800 and square 500 separately and add those together. So you should do that. Which gives us 890,000. Pretty big numbers we're dealing with right here. And then we have 2 times 800 times 500. You can probably hear my calculator clicking in the background. That's okay. And that's 800,000. And I'm going to run a space again. So, and then cosine 102. At this point, I would put that entire thing under a square root. Cosine 102. And then I would find out what the length of side W is. And that gave me a length of 1027.8, and it has a unit, so you need to use the unit of meters. And that is the end of the lesson on the law of cosines.